The other day we talked about solving trig functions, and remember we solved them pretty close to how we solve normal equations that have, like an x in it. We isolated our variable, or we used the quadratic formula, something like that. All right, so an example of something that we did a couple of days ago was if I said solve tangent squared theta minus 5 tan theta plus 6 is equal to 0. Okay, we said, well, this pretty much looks exactly like a quadratic. That would be of the form x squared minus 5x plus 6 equals 0. So I can solve it just like I would solve that quadratic. I can try to factor it, I can use the quadratic formula, but now instead of x's, we're using tangent thetas. Okay, but we can also solve equations that have trig in them, but sometimes they'd be a little trickier because they're going to have more than one trig function. Okay, so this is solving equations with more than one trig function. Okay, and since the issue is that we're going to have more than one trig function, we're just going to do everything we can to either make it so we only have one trig function or break it up. So let me give you an example. Okay, so let's say solve for theta when we'll say 0 is less than or equal to theta, which is less than 360. So this we want in degrees, not radians. Okay, and let's do 2 cosine squared theta minus sine theta is equal to 1. Okay, so this is what I'm talking about. We have an equation right now where we have a cosine going on and we have a sine going on. So right now, this would be like if we had 2x squared minus y equals 1. Okay, here, it's kind of difficult. We have 2 different variables and we only have one equation. We don't have something else where we can substitute. We can't use elimination or anything. So this, we're kind of stuck if it were using x's and y's. Okay, but remember, we have all of these other different trig identities and trig formulas of different ways that we can write things. Okay, remember, we always have our Pythagorean identities, which is sine squared theta plus cosine squared theta equals 1. We always have, I was going to write that in the wrong order. We have 1 plus tangent squared theta equals secant squared. Okay, so this one's nice because it gives us a different way to write secant squared, but we could always subtract the 1. All right, this is just like your cis quizzes. And we get that tangent squared is equal to secant squared minus 1. So that would be a different way to write tangent squared. Well, in this case, I've got this cosine squared and this sine. Well, if you look at this Pythagorean identity, we can rewrite this so it's just cosine. We can subtract sine squared from both sides. So let me erase this, make it a little nicer. So if we're starting with sine squared theta plus cosine squared theta equals 1, well, if I subtract sine squared from both sides, I get that cosine squared theta is equal to 1 minus sine squared theta. That's awesome because that means that I can take this, and since that's equal to cosine squared theta, I could substitute that in here, which makes my life a heck of a lot easier because now I've got 2 times 1 minus sine squared theta minus this sine theta equals 1. Now I have everything with just a sine theta. So I can distribute and get 2 minus 2 sine squared theta minus sine theta equals 1. And now this is just a quadratic that we can get equal to 0 and we can factor, use the quadratic formula. So I'm gonna make it so the square is positive, so I'll add over to both sides, so I'll end up getting 2 sine squared theta plus sine theta minus 1 is equal to 0. So I got this equal to 0. And then quadratic formula or factor, this does actually factor. Okay, remember, whatever goes in the front of your parentheses is what multiplies to your first term. And then whatever goes in the end has to multiply to your last term. Well, my last term's 1. The only thing that multiplies to 1 is 1 and 1. And I want to get my sign, so when I FOIL this, I'm going to be left with the sine theta in the middle. So that's going to be a plus and a minus. Okay, so then we get that 2 sine theta minus 1 equals 0, or sine theta plus 1 equals 0. So now we're just solving this like a normal equation. All right, do a little t-chart. You could have used quadratic formula. You get that sine theta is equal to 1/2, or sine theta is equal to -1. Now we can go ahead and take the inverse sine of both sides. I'm going to do this one first. Sine theta equals -1. That's just 270 degrees. There's only one possibility for that one. But when we do inverse sine over here, so we're doing the inverse sine of 1/2, that's going to give me that theta is equal to 30. But remember, sine is also positive in quadrant 2, so I got to find what my quadrant 2 possibility is, and that's going to be 180 minus 30, or 150 degrees. So this is just like what we were doing the other day, solving trig equations, except now we have the added step of having to deal with having 2 different trig functions inside of one problem. Okay, let's do another example. Let's do another one. Let's do cosine of 2 theta minus 2 sine theta plus 2 is equal to 0. Okay? Again, we have an issue because we have both cosine and sine rocking in this. Okay? But again, you have this reference sheet that has all of these trig identities on it. Use it. Okay? Now, remember, we have all of these special identities for when we have half or double angles. Remember, we did problems with sine 2 theta, cosine 2 theta. We did sine 1/2 theta, cosine 1/2 theta. So right here is the perfect example of one of those double angle identities. On your reference sheet, it will tell you that cosine 2 theta is equal to something, and one of those happens to have a sine in it. So we can substitute cosine 2 theta for 1 minus 2 sine squared theta. Okay, I took that off of my reference sheet. It flat out says cosine 2 theta is equal to 1 minus 2 sine squared theta. And then I can just bring down the rest of this crap, because now I have everything in terms of one trig function. I've got a little simplifying to do, but now everything's got signs. I can treat this like a normal quadratic. So we can simplify this, move everything over. So I'll have sine squared theta plus 2 sine theta. That'll be, I'll subtract the 2, and then I'll subtract the 1 minus 3 is equal to 0. And this one does not factor, so we would have to use the quadratic formula. So sine theta would equal negative b, so -2, plus or minus the square root of b squared minus 4ac all over 2a. Be careful, your c is -3. So when we do this, we get -2 plus or minus the square root. Now 2 squared is 4, and a lot of you guys are making this mistake. When you multiply all of these, you have a minus times a minus. This is going to be a plus in here. 4 times 2 is 8, times 3 is 24. All over 4. And then we can simplify. This is -2 plus or minus the square root of 28 over 4. And then that is what you are going to put in your calculator. All right, you're going to have two different options. We're going to put, because this is what this is what sine theta is equal to. So we have sine theta is equal to -2 plus the square root of 28 over 4, or sine theta is equal to -2 minus the square root of 28 over 4. So we still have to go ahead and do our inverse sign. Put it into your calculator exactly like this. Okay? Now when you do this, one of them will work and one of them won't. Okay? I think when you put the one with the plus in here, this is going to be too big. But we go ahead, we do our inverse sign, we end up getting that theta is equal to 55. Theta is going to be equal to 55 degrees. And that's just our quadrant 1 answer. We can also do our quadrant 2 answer, which would be 180 minus 55. It's a horrible 180. So always have to do every possible answer. But again, we're just substituting in to get this in terms of the one trig value, and then we can go ahead and solve it like we always would. Good. All right, and then I want to do one more, just one. Okay, because this one's a little weirder. Let me find it. Okay, let's do 2 cosine theta sine theta. Woo. 2 cosine theta sine theta minus cosine theta is equal to 0. Okay. In this case, there isn't really, well, first off, we do have 2 trig functions. We have cosine and sine going on. Okay, but notice we don't have like a cosine 2 theta like we did in the last one. We don't have something where I know an identity to substitute in for it. Okay, but notice I do have a cosine theta in both terms, so I can factor out a cosine theta. And when I do that, I'm going to be left with 2 sine theta minus 1 equal to 0. And now that you have this broken up, this factor just has one trig function, and this factor just has one trig function. So that's actually nice, because we'll have cosine theta equals 0, or 2 sine theta minus 1 equals 0. And these are both solvable because these both just have one trig function. So for the first one, we'll take the inverse cosine of both sides. We'll get that theta is equal to 90, or theta is equal to 270. There are 2 possibilities that have a cosine equal to 0. Okay, on the other side, we'll add 1 divided by 2. This is sine theta is equal to 1/2, which is going to give me that theta is equal to 30 degrees. That's my quadrant 1 answer, or my quadrant 2 answer is going to be 150. Okay, we'll do a lot of practice with this tomorrow, but it really is the same thing that we've been doing, except now you might just have to get a little crafty with substituting in, so you have trig functions that you can actually work with.